Hello, everybody. Welcome to the session. This is really disorienting to be in my own silent disco, but it's something maybe I've always wanted. Today, I'm going to be talking about our speech recognition product that we just announced. So it's kind of one half of the speech recognition and understanding product that Jeff demoed. Today, we're going to talk through the background, kind of like why do we build this product, how do we build it, or talk a little bit about technology, and then we're going to do a very thorough guided walkthrough through the API. Lots of code, a couple interactive demos, so keep your phone handy. And then at the end, we're going to talk a little bit about some of the business cases that we saw for this API as we went through the developer preview with some of our customers. So to recap Jeff, he got to do the big reveal, but here's the gist of it. It's speech recognition is an API for converting speech to text. It's built directly into Gather, which is the primitive we have for collecting user input. It's available today in public beta. 2 cents per 15 seconds, offers real-time results, and offers 89 languages and variants right out of the box. We just shipped the docs this morning to the Gather docs. So if you want to follow along on your phone or laptop as we walk through the docs, it's there. So to start, we're going to do a little bit of a demo. This is kind of the traditional Twilio demo, a couple core components. It's written in Python using Flask as a framework. We're using the Twilio helper library, and we're using this incredibly useful utility called ngrok that lets you sling requests to your local host from the internet. Cool. So to kind of give you an idea of how this is set up, I have a phone number I've purchased from Twilio, an 818 number, and I'm pointing it to this URL, akjordan.com/ngrok.io.incoming. That then flows to ngrok, which is the tool I have running here in my console. And all this is doing is taking this URL and exposing it as a port on my local machine. This is just so Twilio can talk to my local. And then I have a Python process here running. Make sure I have the right one running. Cool. So to start off, we're going to walk through like the really basic case for speech recognition. And as you can see, if you're familiar with Twilio's existing gather verb, this is a very, very little modification. So the only thing that's different and new about this verb so far is we've added a new parameter called input. And input now takes one of 3 values. It can take DTMF, which is your vanilla gather. It can take speech, or it can take DTMF speech. So now I'm going to call in. And I've written this small callback function. What this callback function is going to do, it's going to take the results of the gather, which are posted to the action callback. It's going to look at that request, and it's going to pull out a parameter called speech result. And speech result is going to contain the results of my speech. And then it's going to write them to the console and also read them out for me.
Welcome to Twilio Speech Recognition. Please say hello.
Oh, I can't hear it because it's... Sorry. Hello, hello? All right, we're going to try this one more time. Sorry. Can't hear my own demo. Oh, look. I can't hear this. Sorry. All right, no, it works perfectly. Yeah, so that's the really basic case, but we can make it a little more complicated. One of the really nice things we get from using the Google Cloud Speech API is real-time results. So if I bring in a little block of pre-written code, because I'm not quite as adventurous as Jeff is, we can also handle the partial results, and we can do that by adding one additional parameter, which is partial result callback. And for this, we're going to pass in. So this is going to do something very similar. It's going to, as I speak, as I say words, and they're recognized, and we get those recognitions back, we're then going to post those partial recognitions to this endpoint. This endpoint is going to pull out a couple different values. So the first is a sequence number. So we send each partial result to you as a webhook. Webhooks are really easy to use. They also have this nasty habit of there's absolutely no order guaranteed. So if order really matters to you, having a sequence number allows you to reassemble on your side. An unstable speech result. So this is the part of the speech that the engine's still chewing on. This may change. In fact, you'll notice as I speak, it does change. And then stable speech result. This is part of the speech that the speech engine has made a finalized determination on and will no longer change. Headphones on. All right. Call back.
Welcome to Twilio speech recognition. Please say hello.
Hi, this is Andrew, and I'm doing a speech demo live on stage, and I'm getting streaming results.
You said hi, this is Andrew, and I...
Cool. So as you can see, it's really, really easy to take these real-time speech recognition results. We've seen people do things like calculate sentiment in real time, or allow their applications to be more responsive by, as opposed to waiting till you hit the final result to parse it, as each callback is sent, evaluate that phrase, and determine your next action. It allows you to build a much more responsive application. Cool. So Jeff covered this in his keynote, but kind of like why now? This has been a really long-running request for Twilio. People have asked, you can do DTMF, how do we do speech? And the big thing is that the state of the art has come a very, very long way in not so long. So where before there was a ton of complicated training you had to do, you had to figure out acoustic models. Languages were something you bought a la carte. So we've seen customers order forms from various previous vendor, and every language is a different line item. And if you didn't plan to have enough ports of German, you just weren't going to be able to do German recognitions on that given day. And also, everything was an upfront cost. So you amortize that over 7 years. Put down low six, high seven figures, depending on the size of your implementation. And then there was the professional services. You didn't really know how to tune this stuff. If you did, you either hired a specialist in-house or you brought in someone to do ProServe to tune this stuff. But we've seen in the last couple of years, the state of the art for speech recognition has come a very, very long way, very rapidly. And now you have cloud providers who have very robust acoustic models and very wide codec support, incredibly broad language support, cloud scale. So you don't think in terms of ports, you just think of, you sling requests at it, and the more requests you sling at it, it's still going to soak it up. And really, the best thing, per use pricing. So you don't have to worry about calculating your ports up front, capacity planning. You throw traffic at it, and your costs scale linearly with your traffic. So kind of what is Twilio doing in all this? At the core of this is our new media framework, which we've been working on. And that's allowed us to do things like answering machine detection. It's allowed us to do speech recognition. We're doing speaker detection events within conference and a few other things. And we'll be delivering a number of new incremental products for the rest of this year based on the same framework. Effectively, it lets us to take SIP, WebRTC, and PSTN calls, so any of the call modalities that we currently support. We take those media streams, we treat them however they need to be treated, fix them up, insert silence, buffer. Allows us to handle Barge and DTMF detection, so there's a bunch of kind of additional media features we implemented on top. And then we take that media once we've treated it, and we shove it into a gRPC channel and stream it to Google Cloud Speech. And then as they hand us back results, we take those, process them in Twilio, and depending on how you specified, or what parameter you specified, put them into a webhook with all your familiar Twilio parameters and pass them back to your application to act on. So kind of why did we use gather? We thought about doing additional verbs. Is this listen? Is this stream? We looked at gather for a couple of reasons. One, it's already well established as a primitive for user input. If you want to take input from your user, you're already doing this. And this allows you to take your existing applications, which are already built with Gather, and upgrade them with speech with a single parameter change, and not have to worry about giving up the functionality of Gather to take on speech. We also allows us to support press or say. So we've all heard an IVR, press N or say Y, allows that. And it's kind of minimum complexity, right? We can do this with a single parameter, and we don't have to reteach you a whole new set of parameters for dealing with speech. So kind of what did we add? For the power this adds for you as a developer, we didn't add a tremendously large number of parameters. So for Gather, we added input, we added hints, barge in, language, and then the partial result callback URL that I discussed earlier, and a method you can choose either get or post. For action, we added just 2 parameters, speech result and confidence. And then for the partial callback result, we really just added the parameters that we discussed earlier. So the 2 big ones being stable and unstable. So let's talk a little bit about timeouts. So if you noticed in Jeff's demo, at least for me personally, there was a heart-rending 4-second delay between when he spoke and when something happened. That's because the speech timeout was set to 4 seconds, which is terrifying. So 5 seconds is the default, a little too long. 1 second is possible, but probably too short. The timeout starts evaluating from the time that you're internally, the verbs you have nested within your gathers stop executing. So I'll talk a little more about that in the code. 2 seconds is about the Goldilocks number. So let's kind of dig into that a little bit with the code. Cool. So we have this welcome, gather callback, inputs, and so we can kind of hear the default speech timeout if we call back.
Welcome to Twilio speech recognition.
Hello,
Please
this is
say
Andrew,
hello.
and I'm saying a thing.
You said hello. This is Andrew.
Cool. So that's like fine, but could be a little nicer. So we think that like timeout, bump this down to 2 seconds.
Welcome to Twilio speech recognition. Please say hello.
This is a shorter timeout.
You said this is a shorter timeout.
Cool. So that makes it feel like a little more responsive and lifelike. So if there's also kind of a, if you're bold, timeout 1 is a little dangerous because the timeout starts rolling from the time the Twilio finishes executing the nested verbs within gather. So I have this gather verb, and nested within the gather is the say verb. It's actually easier to see if I do this. So this is the TWIML that this code is actually generated. And you can see I have this open gather tag, and then the say sitting within the gather, and then this close gather tag. And so the timeout starts evaluating from the second we say the end of hello, which makes a 1 second timeout really inconvenient sometimes because you end up potentially like timing out before the person even starts speaking. So another way to do this is to pad out the time with like gather dot pause length equals 3. So if you do that, you can append a pause to the end of your gather. It kind of gives you like 2 layered timeout. One is like the initial timeout, and the other is the timeout for like mid-speech timeout. Cool. That's an int. Cool. So another thing you can, which is really, you need to see this, sorry. Another thing which is useful are hints. So hints are a really, really powerful way the Google Cloud Speech offers to boost their model. So they have a very robust base model that allows you to, it covers like a ton of common domains, and it does a very good job in most cases. There are some cases where it's not going to know the proper name of your people, place, or thing, and that's where hints come in. They're also really helpful if you're hacking around and want to force like ambiguous digit presentation into a single format. So you say the word to. Is that TWO, TOO, or the numeral 2? Hints is a good way to force that. So if we do something like
Welcome to Twilio speech recognition.
1, 2,
Please say
3,
hello.
4, 5, 6, 7, 2, 3, 4.
You said 1, 2, 3, 4, 5, 6, 7.
So here, it's making some decisions about like whether I'm talking about numbers or numerals. And it's doing actually a pretty good job of understanding that halfway through that I probably mean numbers. But one of the ways you can force that behavior is passing in hints.
Welcome to Twilio speech recognition. Please say hello.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Cool. So that's really effective. The case I was trying to demonstrate for the longest time was that it didn't do Twilio super well, and it now does Twilio really well. So who knows? Cool. So this I did as a lark. I hacked this together this morning, so this most likely works. Out of the box, there is a massive, massive amount of language support. 89, in fact, of languages and language variants. So if you have your phone out, I was trying to figure out the best way. Like, people speak a ton of languages, but you have to specify the language up front that you want to recognize, because it's kind of like, would be unbelievably impressive to automatically determine it. So the way this demo works is if you text one of these case sensitive, I threw this together this morning, but if you text one of these strings to that phone number, so like ENGB, and speak to it, if you text to it, it'll call you back. That call is set up with a gather session in that language. Whatever you say to that gather section, it will then text you a transcript in that language. So kind of give it a shot. If it falls over, I'm sorry, but it should work. Here. I'll do it too.
You chose NUS as your language. Please speak away.
Hello, this is Andrew, and I want you to transcribe what I'm saying and shoot me a text message. Thanks. Cool. So hopefully you get the gist of it. People are getting calls. It seems to be working. Cool. But the point is, it supports really, really good language support in a really wide range of languages. So wherever you're trying to deploy your application, this will get you take your user's speech and transcribe it into text really effectively. So one other thing, which is kind of non-obvious, is Barge. So this is a feature we built, kind of a media feature to help you build more responsive applications. So if you notice, I can take my existing.
Welcome to Twilio speech recognition.
Stop talking, please.
Say
Give
hello.
me to an agent.
You said stop talking. Please.
Cool. So you can configure whether or not you want to cut off all the nested verbs within your gather. So if you have a really important message you want to make sure your user wants to hear the whole thing on, you can flip Barge to false. Otherwise, you can flip Barge to true. But pretty useful either way. So I'm going to walk through like a really simple use case for how you can use speech result. This is something that I built for my apartment. So if you want to upgrade your front door, how would you do that with speech? So right now I have, that's what I want. My front door is hooked up to Twilio, so every time someone calls my door buzzer, it like executes a TWIML application, and right now that application just looks at some digits I press, and depending on the digits I press, pops my door open, because my door will accept like DTMF digits to activate an electronic lock. So what I can do is take this speech result and call lower, and then say like if open sesame in speech result twiml dot say. All right, so I'm listing for just the phrase open sesame, and if that's correct, it should pulse a DTMF tone and pop open my door.
We are sorry. An application
no.
error
What have I
has
done?
occurred. Goodbye.
All right. I'm going to not try to debug this live.
Sorry. An application error.
Well. All right, T-Mobile, don't do this to me. Oh, that's brutal. All right, well, that is not important enough to keep trying to make it work. What are some slightly more practical applications? So we kind of see the applications that our customers were building on this fall into 3 different categories. So the first, which was actually kind of surprised us when we launched this product, we assumed that everyone would go for IVR. This would be used for kind of navigating menus. But we saw our most dominant use case is speech form filling. So this is people who want to call in and collect information from you to help you do some kind of business process. So it could be buy home or auto insurance. It could be finding an apartment where they need to ask you a series of questions, and based on the questions they answer, they're going to kind of progressively move you through a form. You can kind of think of this is just like an HTML form, but for your voice. The next one is IVR navigation. So we kind of bundle bots in this too. This is anytime you're calling into a phone number and you want to use your voice to do some kind of automated processing. And the last is agent routing. And this is where we kind of see our customers doing this, where they want to call in and use voice to pre-build a profile of that person before they send them to an agent. I have a demo here, but if you want to call into this number, it's a demo that does some IVR form filling, but we're running a little light on time. This is kind of like the flow where we saw most of our people working. They're going to start with speech. They're going to take that speech, use speech recognition to turn it into, into text. That text they're going to throw against an intent engine. So we've seen people use a variety of intent engines. So Understand is one of those. We've also seen our customers use API.ai, the Stanford classifier, OpenAI. So there's a ton of existing classifiers, and they kind of, once they have that intent, they shove it into one of 2 things. The top is kind of what one of our customers is doing, is those intents are then shoved into Task Router to create routing data for agents, and that data is then that call is then routed to an agent. And the bottom one is do something automated. So that's kind of the demo Jeff showed, where using Alexa to book you a flight, and or to kind of do something else that's automated. Cool. Before we go, I'd like to thank my counterpart over at Google. Dan Herron is here from the Google Cloud Speech team. He's going to be outside. We're taking questions outside afterwards. This is Dan. I want to thank their team for helping out. They have really, really amazing technology, and we appreciate them helping us get up and running with this. They're building a ton of other interesting stuff. For signal questions, we take them outside in the sessions. So I will be outside under that Jackson side right after this. Would love to talk more about speech or how you want to use it. And we can't wait to see what you build. Thank you.